All right, you guys, so we're going to do this anodizing real quick. I don't even know what part is. Apparently, I'm number dumb. I think this is part 6, but I could be really wrong. Anyway, what we're doing is we're going to anodize. We're going to anodize this snowflake. I still don't even know what color we're going to do because it has these little speckles on it. So I can't do green anymore, and I can't do gold. So I really don't know what. I'm going to set this tank up real quick. This is a rectifier. It's 12-volt power source, and if you're brand new to anodizing, this is exactly what you want to get. You go on Amazon, they're like $50, dude. So like, here's one from Caswell, the company that's, they make all that shit. They're like name brand, right? Like they're your Bentley of anodizing and plating. That machine's probably like $200-300, $200 from Caswell. You can probably look it up if you want. And this one right here is the same one I got already. You can see how I've been using this one. Same thing. This is a Longwell from Amazon, $50. Does the same job. And if you're not a scientist, I've been doing this for 5 years. So when I started with pool chemicals, pH down, and a battery charger for a car. And you can do all that, but you just get better results with better equipment. But if you're brand new, only thing you have to do with this is turn it on. Like, you don't have to worry about the science, the math of all your part. You just turn the voltage. I'll show you. And I'll show you exactly right too. So you turn this voltage, right? You turn it down, it goes down, and we're doing a 12 volts. Like, it's pretty standard on anodizing. There's no reason to not be doing 12 volts. That's why a battery car charger will actually work for this. Now, a battery car charger, you lose the ability to control the amps, right? It's just whatever amps it decides to push into you. And if you have a part that's sensitive, you don't want to push. You'll never be able to get an even surface if you're not able to control the amps and the watts. Anyway, enough of the science, because I'm not a scientist. What with these ones are so simple. All you have to do is take the current and twist that knob all the way to the right, all the way until it'll feel like it'll never go. You'll take you 2 minutes sometimes to twist that knob. You're twisting it all the way to the it's clockwise. Once you're there, all you have to do is hook the part up and it'll self-adjust to how many amps it needs, unless you're going for a specific desired finish, thickness. Then you can adjust this and control how much layer. And that's only relevant if you're doing like bearing cups and they need to fit a certain tolerance, or if you're doing professional work for a company or something. But if you're doing your own parts, you'll never run into a reason why you have to control that. I've been doing it for 5 years and I haven't even learned that. I know the math, but I've never had to do it. It's never made more sense to do that extra work for the finish I get. So those are the easiest machines to use. Man, you're putting battery acid in something and you got to heat it up, so you can't use metal. You have to use plastic. And for this process, I'm only anodizing. I can't touch the part no more. I'm only anodizing the teeth and the lettering right now, right? I don't care about the face and the backside. I'm going to sand them down, polish them, and re-anodize them twice, different color. So I'm only doing one step. I'm going to anodize the part, and then the other step is I'm going to seal it. I'm going to skip the desmut. There's another step in this process where you would have a tank with desmut, and then you would have a tank the same size as that one, and it would have distilled water, and there would be another tank with sealer, right? And all these tanks would be the same size. That way, when you have a part hanging in the tank, you can just pick the bar up and move it into the next tank and set it on the rails the same way, and you don't have to worry about fumbling around with the part. When you start fumbling around with the part, it could fall off in the tank, and then you got to start all over. You got big problems. It's best to have even sized tanks all the way down the line. So you're just picking it up, moving it over, dropping it in the next tank, picking it up, moving it over. It's simple. This would cause you absolute hell. But because all I'm doing is anodizing it, distilling it, and throwing it into another metal tank that I don't have to hang it in, I don't care. When I'm sealing my part, it doesn't have to be hanging. It can just be sitting in the tank, touching. Every other step, it has to be hanging and not touching the tank anywhere. Play that back and it'll make sense. Once again, we're heating up battery acid in water, bro. So you can't have anything in there. You can't put this in metal and heat it up on fire. you don't fucking do that, by the way. I did that for years until I was persecuted by some guy. Anyway, long story short, you can't do that. It's very toxic. It can kill you, so you don't heat the acid up with fire. So to speed this process up, I took 3 gallons of distilled water, okay, and I put them on that burner right there. 3 gallons. And I got it up to 90 degrees. Ooh, shit, it's probably only about 75 or 80 right now. So with that said, that's battery acid, right? Just you go to Interstate Batteries and buy it in a box. It's like $35 for 5 gallons of battery acid. It's the best way to do it. I haven't used this one yet, obviously. I'm just setting up my tanks. So you just cut that off, tilt this into that bucket right here. Put exactly 1 gallon of battery acid in there. I'm gonna do that right now and then continue this video. All right, check it out. It literally don't get no sketchier than this, man. You know? Just pour it out, drain it in there, fill it up. Wear safety glasses, you know what I'm saying? You don't really need gloves, I guess. All right, you guys, obviously, you know I was just kidding, right? I'm aware you don't need gloves. That was a joke. But from this point on, like, my opinion doesn't matter. It's actual science. Dude, that's all there is to it. You can't F this, you can't fudge this at all. I'll teach you how to make every single mistake there is to make and then how to fix it on the back end. But, like, you can't F this up. As a matter of fact, it's so important to get this right that I have this machine run on an alternate power source. Just this machine alone, hooked to a machine just for doing this. Because I've lost countless hours worth of work having to re-prep surfaces because I was interrupted in the middle of the anodizing process. Generator ran out of gas, somebody came over, somebody tripped over the cord, or my dog, or, you know, the wind kicked up and knocked over a fucking tree from the neighbor's house and it flew over and knocked over my pipe. I'm just saying, everything has happened that has interrupted the process. So I have a direct system just for this. You cannot interrupt this when it's happening. You need it for an hour and a half, right? 90 minutes. And that's all depends on how you want the thickness of your part and the color to stand out. Like, you can anodize it for 2 effing hours if you want at 12 volts, and you're gonna get a deeper color because it's gonna be thicker, right? A thicker finish. Okay, distilled water. There's science behind the distilled water, man. There's a positive and a negative charge going on in the water, and the distilled water is charged a certain way. There's, like, I'm not a scientist, but I know these things from experience, from what I have learned. Anyway, so 3 gallons of distilled water, 1 gallon of battery acid in this here bucket. You must add a 1-to-3 ratio. 3 gallons of distilled water, 3 gallons of acid, 1 gallon of distilled water. What, 6 gallons of water, 2 gallons of acid? Figure it out, dude. You just keep doing that. Most important thing besides safety glasses is always pour your acid into the water, bro. Never pour water into the acid. It's not going to effing explode on you or nothing, but what it will do is splash in your eye. And if the consistency of more acid is in there, the splash will be a drop of acid. But if you're pouring acid into water, the splash is going to be more concentrated for water instead of acid, therefore hurting you far less. So then you go ahead and dump the 1 gallon of acid, standard car battery acid for your battery, for your car, that's it. 3 gallons of distilled water. I'm gonna pour that in there right now. And remember, I heated this up, so if all is well, it should be, I poured it, so it's gonna cool down. It should be at least 80 degrees for me. That's good, 85, 86, okay. This has to be at 70 degrees. Dude, I didn't say 69, I didn't say 72, I didn't say 71.5, I didn't say 73, or I didn't say for 45 minutes at 72 degrees. No, 90 minutes at 70 fucking degrees. No variation. It cannot change, but it's gotta stay. So you get it, I heated it up first so I didn't have to sit here and wait for these stupid little fish heaters to heat it up, because it's actually 40 degrees out here right now, ambient temperature. So you put at least 2 little fish heaters on 72 degrees. That way your temperature will actually settle at 70. And if you're depending on your fish heaters, you may have to adjust them up or down depending on how cold it is outside. You must maintain 70 degrees. This is simple, dude. Negative alligator clip to a piece of lead going to your negative outlet. Positive going to titanium. Titanium. I didn't say it is aluminum or steel. This must be titanium, and it must be the best quality that you can buy it. The better quality titanium, the better electricity flow will go through it. Therefore, the better conductivity to your part. Titanium. I have it wired together because I couldn't find a bar this size, this long. Stupid Amazon, I tell you, you don't know what you're buying. So anyway, so that's wired together with titanium wire. Yay. I'm gonna go ahead and mix this acid right here. And like I said, it's 85 degrees. So by the time I pour that 50 to 60 degree acid into there, it should level out at about 70 degrees. And here's a trick to the trade, right? This is something you don't learn every day. Over here, we're gonna keep this guy on the burner. Right. I don't really need that right now, but when it gets hot, I will. I don't, but it's just an idea for you. Water bottle. Keep it at about 110 degrees. Right? Then, if this all of a sudden something happens and I turn my back and this has dropped 2 or 3 degrees, you can just toss this water bottle in there and let it float, and it'll heat that water up real freaking quick, and you can maintain temperature. And if you go over, like if it gets too hot, then you just put cold water bottle in there and bring the temperature back down, and you can juggle it and maintain it with a hot and a cold water bottle. It literally will save your life in the middle of the process. Sometimes you get busy in an hour and a half time, you're doing other parts, prepping other things, you turn around and you're like, oh, F, dude. Well, that's an emergency fix. So I'm gonna go ahead and mix these real quick. I'm gonna pour that in that, and we'll be right back. All right, you guys, one thing before we anodize this, or before we get this part in the anodizing, I'm touching the part, right? Congratulations for me, but if you see I'm touching it in the spots where I'm not going to anodize it. I'm touching it on the back, touching it on the face. I'm not touching these cracks because I've already degreased them in the last, Anyway, so somewhere the titanium wire needs to anchor, right, into somewhere to hang the part, right? You can hang it from the center of the part, but oftentimes it sits at too much of an angle, and you run the risk of it popping off of the hook. So I'm going to hook it in here. Now, in order to hook this part, I'm going to use a tiny little Dremel. Dang, dude, that shit. You're never going to see that. I don't know what I'm trying. Tiny little Dremel bit, like a little tiny rounded Dremel drill bit, rounded for cutting. And if I were you, I'd be wearing gloves so you don't accidentally touch the part like a mistake, but I don't think I'm gonna do that. So I'm just gonna go through and take this a little bit off right there. I'm gonna make sure I have raw aluminum, a good place for the teeth to grip, or for the hook to grip. Dude, my thing, it's not plugged in. Hold on. Alright, so and you have to do this with every single part you anodize. You always have to be looking for a spot to hang a hook that's non-invasive. Okay, I'm gonna grab a piece of titanium and we're gonna hang this. Alright, I got titanium. It's pretty decent thickness, you know what I mean? It's not too bad, but it's not too skinny either. So, let's see, make sure you can see this. Yep. Remember, I took off right here and right here, so I'm gonna squeeze it, right? Because it shouldn't bend. That's why titanium's super stiff, right? So when I squeeze it in, it's gonna hold it. In theory, you don't always get that lucky. is. Oh, see? Yeah, hold on a second. So what I gotta do, I gotta bend this back out. Give me a second here. If I get it, it's hard to do at this angle. Give me a second. All right, so I actually ended up hanging it in the opposite direction, up and down. It just did not want to. It just didn't want to stay in that hole in that way. Sometimes you got to let it decide where it wants to go, because you have to be able to do that. If you don't do that, dude, you're gonna lose the part at some point. All right. And I'm gonna go right in distilled water to rinse off the little metal residues. And like, to be fair, there is a step before this called desmutting, where you would have another heated tank with a desmut solution, and that would take off like all your imperfection, your metals that may be on there, copper, zincs, and all that shit. It cleans it all off. Supposedly makes it a better surface. Legitimately, I don't know the difference. I can't tell. So much to the point where I don't even waste time with it. And it also dulls out the surface of your finish a little bit more and makes it less drippy when you're done. So we got that. I'm just gonna check temperature on this tank real quick. This is that acid, 78. I'm about to go ahead and put a cool water bottle in there for a second and speed this up. Hold on. Right on. So we put it in there, just a big water bottle. Just gonna wait for this temperature to drop. Better hurry up. Alright, you guys, I'm going to show you how to fix mistakes, and a mistake I made already. So I misgauged the temperature of outside, so instead of adding water bottles that are only 55 degrees out here, I just added a little more water and a little more acid to the tank. What do you know? Brought it down. And also, we have different temp guns throwing different temperatures. So right? So I'm just gonna go ahead and assume that we're right on. But just so you know, that's something to be wary of. Like, these things don't, man, look, they're burning up. Look at how I use these. All right, so we're ready to run the part. It's just sitting here chilling in distilled water. All right, comes in here. Dang, I almost just made a big mistake. Fuck, hold on. Turn this off real quick. Man, is there an off button? Hold on 1 second. Alright, well, apparently that machine has a bad terminal. It doesn't want to turn off. But it'll still work though. That's what I'm saying though. You can't miss. Those are bulletproof. Get them on Amazon. Alright, we're gonna put the part in there, and the current is not hooked. The ground is disconnected from the part. So I hung it on that titanium. It ain't touching. It is not touching that lead plate. Right? It's able to free. Because the teeth are becoming silver, it doesn't really matter if it's touching the part on this process. If I was doing a colored part, it couldn't be touching anywhere. It would have to be hanging without touching. So then you just turn the part or whatever, or hang it different on the wire. So, but this will work for this. All right, and I'm plugging in my negative, and then that should self-adjust. Oh shit, hold on. All right. See how it's finding out the spot it wants? Right now, the parts, it's like searching. I'm gonna show you something. You see those little bubbles coming off of the parts? I know you can see that. Hold on. You see that haze coming off the part? Now that is how you know we're anodizing. And this will actually find a spot to rest. Turn it up to 12 volts. So finicky. I'm missing a bit chill. All right, and that's where it's gonna be. It's gonna be at 3.56 amps. And then as time goes on, it's gonna build a layer on that part, and then it takes more energy and more energy and more energy, and the amps will climb up, and that's how you know you're building a layer. Once again, negative to the negative, positive to the part, on a titanium wire, and that thing is not touching the lead plate. I don't have these on because this is so close to the correct temperature at 70 degrees that if the current running through the acid will actually cause like a little tiny bit of heat. And that's enough to heat that tank up 1 or 2 degrees. So it'll actually float at the perfect temperature if I don't use those heaters. So those are not hooked up. I'm gonna go ahead and anodize this for an hour and a half now. And I think I'm going to think about how I'm gonna do this video, because my phone won't sit ambient for an hour and a half without going blank. So I'm actually gonna have to make this a second part. Dang. Yeah, I don't know what else to do, guys. I'm gonna have to end it right here and see you back in an hour and a half, and we'll set up the sealer tank, and we'll get the part anodized silver, sealed, and then I can cut into it with some sandpaper and show you how we're gonna take the face off. All right. Thanks for checking it out. I'm sorry I'm not a good filmer, guys. Like, I mean, you're gonna have to go back into my videos and look for like Crupi chainring restoration video 1, 2, 3, and do it that way, and then maybe I'll figure this out. But for now, this is the only way I can show you. And most of it's not for you anyway, to be honest with you. It's for some certain people that need to know how things are done and what parts are acceptable to send to me and what parts are not, and the reasons why. And this will be a good reason why I won't accept some work, because I'm already limited now to what colors I can do on this part based on the imperfections I showed you. So, you know, it gives a good reason to show a customer like, yo, this is why I can't, or this is, look at your parts closely. All right, that's what I got. We'll see you in the next video, you guys.